Okay, hey, once again, this is Mr. Olive, and this is going to be our third unit on or our third lesson on thermal energy. Um, you should have done Mr. Flugum's and Mr. Marquis prior, and that would set you up good for this one. So here we go. Just a quick review, go over some of the things that were covered by Mr. Marquis and Mr. Flugum. Um, Hot molecules versus cold molecules. So cold molecules are going to tend to move slowly. The faster molecules that make up an object are moving, the more kinetic energy they have, and the more the temperature goes up. So as kinetic energy increases, so does an object's thermal energy. I compare it to a slow dance. That would be like the molecules inside of a metal pipe. They'd be moving slow, and then as you hold it over a flame, it'd be more like a crazy mosh pit. So as kinetic energy increases, so does thermal energy. Um, some materials are really, really hard to heat up, and they're said to have a high specific heat. Takes an awful lot of energy to heat them up, takes a lot of energy to heat water up, for example. And then most metals have a very low specific heat. They heat up super quickly. So if you were to look at the graphs right here, this is again, it's just kind of review. Aluminum, as you add energy to it, it's going to heat up very, very quickly, and water is going to take an awful lot more time to heat up. There's a chart there on the right you can look at. You can even pause this and look at it, but it just shows that water about 4 times as much as Okay, so as you look at the chart there, you'll see that water has about 4 times the specific heat as air. So it takes quite a bit more energy to heat water up than it would air. And that comes into play later when we're talking about insulators. Okay, so thermal energy, as was talked about in some of your other lessons, thermal energy transfers from one medium to another medium 3 different ways. One of those ways is radiation, one's conduction, and one's convection. And you're going to hear the term medium again. And just to remind you, medium is whatever matter thermal energy might encounter or pass through. So if you look at the picture on the left there, you can see space and then our atmosphere and then our Earth. Space is a vacuum. There's no matter at all in space, or not really much. And so thermal energy it would not be passing through any medium until it gets to our atmosphere, and then it would be passing through air. Air is a medium, water is a medium, any solid that heat might pass through would be a medium. Okay, so one of those examples was conduction. Conduction is faster moving molecules transfer directly to slower moving molecules. So when I think of conduction, I think of direct contact with a heat source. So for example, that snowball that's being held by somebody's hand, you don't transfer cold to a hand, you transfer thermal energy to the snowball. So what you're feeling what you think of as cold is actually your body's heat leaving you quickly. That's what causes that cold feeling. Cold isn't really a thing in science. It's thermal energy leaving you quickly. But anyway, that direct transfer of faster moving molecules, say up that fire poker towards the lady that's holding it, that's going to be conduction, direct contact. Another form of thermal energy transfer is convection. Fluids like air or water transfer heat by convection. So as their volume expands, their density decreases, and this makes heat flow upwards. So you can see the parasailer riding a convection current, that's heat rising. You can see that the air balloon, as the air inside of that little balloon heats up, it's going to rise, and the person holding their hand over a candle is also going to feel the heat of convection. The last form is radiation, and this is unique in that it does not require a medium. So it's when thermal energy transfers by means of electromagnetic waves. So the ones that we're going to talk about later are the infrared waves, but that can be microwaves and X-rays. And anytime heat is transferring through electromagnetic waves, that's going to be radiation. We get the sun's heat through radiation. It transfers all the way across millions of kilometers of space to Earth by radiation. Okay, so materials that don't allow thermal energy to pass through very easily, those are going to be called conductors, as you guys know, and then objects that, or excuse me, whoops, insulators are things that do not allow thermal energy to pass through, prevent thermal energy from passing through. So like the air that's inside that puffy coat, or the air trapped inside that sweater, the little pockets of air in those wooden spoons, and that pink insulation being installed, that it has the purpose of intentionally trapping air, which will trap heat. Conductors are things that are tightly packed molecules like metals that allow heat to just pass right through. So for anything made out of metal allows heat to pass through. It's why you wouldn't want a pair of aluminum socks, because it would your body heat would just flow right out of your feet. Okay, so you guys are going to get some questions, 8 questions total, and I'm just going to ask that if you're in my class, you answer those things on a Google Doc and share it with me. Mr. Flugum, Mr. Marquis, they have quite ways that they want you to submit responses to them too. So you're going to have 3 choices on most of these questions and just answer them. You can pause this thing. You don't have to go at the speed that I'm going. So you can even go back and look at some of the information prior just to make sure that you have your responses correct. So here we go. Question number 1, who's your teacher, what's your first and last name, and what period do you have physical science? So that's question number 1. Take a second to answer that, and then we'll move on. Okay, you've got 3 choices for question number 2. Different levels of difficulty, just depending on how much you want to challenge yourself. Choice A. The 3 objects in the picture, soup, spoon, and pot, which would have the highest specific heat? Which of those 3 things, soup, spoon, or pot, would have the highest specific heat? Choice B, explain using terms like insulator or conductor why a metal spoon would be a bad choice for stirring this soup. And choice C, this pot has no handle. What would you make the handle out of? If you're going to design the pot, what would you make the handle out of, and why would you choose that material? All right, question number 3 is about snake, particular snake called a pit viper. So things like rattlesnakes belong to the pit vipers, cottonmouths. The snake is a member of a family of snakes commonly referred to as pit vipers. And pit vipers have a thing called a pit organ that can sense thermal energy for hunting or protection. The snake uses a part of the electromagnetic spectrum called infrared waves. So here's your question, choice A. Why does the mouse show up on the snake's pit organ sensors? What about the mouse makes it show up? Choice B, is the snake relying on conduction, convection, or radiation while it's hunting? So you have to think about which of those relies on electromagnetic waves. Choice C, why would the pit organ be such a big advantage to the snake? Being able to see electromagnetic waves like infrared radiation, why would that be a huge advantage to the snake? Think about the difference between mammals and reptiles. Okay, moving on to the next question. Next question has a little bit to do with specific heat. So let's look closely here. Choice A. How are the molecules that make up the horseshoe on the left moving differently than the molecules that make up the horseshoe on the right? And if you're having trouble answering that, go back to the very beginning of this lesson. How are the molecules that make up the horseshoe on the left moving differently than the molecules that make up the horseshoe on the right? Choice B. What kind of energy do the molecules in the horseshoe on the right have more of? So quite a bit more of a certain kind of energy in the horseshoe on the right. And choice C, explain why the horseshoe would probably heat up and cool off quickly. So think about that little upper left-hand part of this slide. Explain why this horseshoe would probably heat up and cool off quickly. Okay, moving on to question 5. Question 5 requires a little bit of background information. The inside of the Earth, the inner core, is as hot as the sun. And as the Earth gets cooler, it gets closer to the part we live on, which is called the crust. The gooey hot part in between the core and the crust is called the mantle. It's kind of like toothpaste, except it's really, really hot. The mantle is always slowly moving, and as it gets heated by the core, it rises up towards the crust, then it cools and sinks back down towards the inner core again. So here's the questions I'm going to ask you on this next slide. Choice 1. Is the mantle up by the crust more or less dense than the mantle down by the core? And why would that be? Choice 2, the movement of the mantle is an example of radiation, conduction, or convection? And please explain your answer. Choice 3, what is the medium through which thermal energy is transferring in this example? So what medium is thermal energy transferring when we're talking about the movement of the mantle? So those are your 3 choices for question number 5. And again, you can pause on that if you wish. Question number 6. A snake on a road. So, yeah, I walk up and down my driveway. I'll see, this time of year, I see gopher snakes laying across our road. Just one choice on this one, okay? So, explain why the snake is counting on all 3 types of thermal energy transfer. How is that snake benefiting from radiation? How is it benefiting from conduction? And how is it benefiting from convection? Remember, a reptile can't make its own heat. So it needs external heat sources. So how is it getting heat from radiation, conduction, and convection? Question number 7. Got 2 more questions. A little background knowledge here in the little green box. Turkey vultures almost never flap their wings. The turkey vultures are the big birds that you see around here this time of year. They rely on the ground to heat up, and then as the heat rises in kind of a corkscrew pattern, the vulture just rides it and it smells for dead stuff, so it can go down there and eat a carcass. Tornadoes occur when the air way up high is really cold, but the ground gets baked by the sun, so the air rushes upwards. Okay, so here's my question for you. Okay? Turkey vultures and tornadoes are both dependent on what type of thermal energy transfer? If you think of the 3 types: convection, conduction, radiation. And then what medium is the thermal energy transferring through? That's your question for number 7. Don't have 3 choices on that one, just have to see if you can tackle that one. Your last question. If you're going to roast a marshmallow and you're going to use either radiation, conduction, or convection, what technique are you going to use? Where are you going to put that marshmallow? And are you going to depend on radiation, conduction, or convection? You have to pick one, and you have to defend your answer. So if you're going to, you could do it any of the 3 ways. They're all available when you're sitting by a fire. So are you going to roast that marshmallow using radiation? Are you going to roast it using conduction? Or are you going to roast it using convection? How would you get the perfect marshmallow roast? I'm going to go back through these questions until I hit my 15 minutes. I don't have much time, so I'm going to boogie back through them. But you can always rewind this, pause it, however you see fit. Question number 2. Soup, spoon, or pot? What's going to have the highest specific heat? B, why would a metal spoon be a bad choice? And C, this pot has no handle, so what would you make it out of? Question 2, couple of choices. Why does the mouse show up on the snake's pit organ sensors? B, is the snake relying on conduction, convection, or radiation? And C, why would the pit organ be such a big advantage to the snake? Don't have much more time. I'm trying to be quick. A, how are the molecules that make up the horseshoe on the left moving